In this tutorial we're going to look at driven constraints and motion constraints. What we're going to do with both of these is create relationships between work planes, and this will allow us to create animated videos in which wheels will move in synchronization. First of all, what we're going to do is we're going to locate a work plane within the rear wheel. So on the left hand side, open up the assembly of the rear wheel, locate the wheel part and open up the origin tab. Working our way down the list of work planes, we want to choose a suitable work plane that we can align to the floor work plane of the entire scooter. In this instance, the XZ looks like a useful work plane to use. Right click on it and turn its visibility on. What we're now going to do is return to the entire assembly, visit the origin box, and looking down the three available work planes, we're going to turn the visibility on of the work plane that represents the floor. So now we have two work planes, one for the wheel and one for the floor. What we're now going to do is create an angled relationship or a constraint between these two. The reason we're going to do this is because it will allow us to then turn this off and drive that forward as part of an animation. So first of all, what we need to do is we need to create a constraint between these two work planes. To do that, visit the ribbon and click on Constraint. We're going to choose an angle constraint, and the first solution, which is a directed angle, is the one we're going to choose. Our first left click will be onto the work plane of the wheel, and our second left click will be onto the work plane of the entire scooter. What we've now done is, as you can see, created a 0 degree constraint, which means that this work plane on the wheel will always run parallel to the floor position. Click Apply, click to close the pop-up window. Now it might seem odd considering we want to move this wheel to lock this wheel in place. What we're now going to do is, on the left hand side, we're going to locate the constraint we've just created, the angled constraint. We're going to right click on it and we're going to suppress that constraint. So effectively we've now turned that constraint off and freed that wheel up to move. Our reason for doing this is because we can now right click on the constraint and choose the option to drive this constraint forward. If we now click on the play button, what you'll see is the wheel will move through 10 degrees quite quickly. The start position of 0 degrees and the end position of 10 degrees can be modified. So if we enter in 360 degrees and press reverse and press play again, we can now get a full 360 revolution of the wheel. And if we click to reverse, we can return back to its original position. If we click on the More option in the pop-up box, we can now change both the step and the repetition. So if we increase the step to 10 and the revolution to 4, we're now going to create 4 revolutions of the wheel at a much faster pace. If we now click to play, you'll notice the wheel moves much quicker. Now that we've created a driven constraint on the back wheel, what we're now going to do is pair up the back and the front wheel so that they move at the same time. So as we rotate this rear wheel, the front wheel will rotate as well. To do this, we need to create another constraint. This time, from the ribbon, select under the tabs a motion constraint. We're going to choose the first motion constraint, which is a forward motion. If we were working with connecting gears, we might choose to use the reverse constraint, but in this instance both wheels will need to move forward in the same direction. So we click on the forward constraint. This time we're going to click onto the surface of the wheel. So we're going to look at the wheel and choose a front flat face, which is that one there. We're now going to select from the rear wheel the front flat face and click Apply. If we now close the pop-up box and click on the rear wheel and drive it forward, you will see that the front wheel drives forward as well. And if we reverse, it will also reverse. The relationship means that these two are now tied together. What it means is, if we return to our angled constraint and drive it once more, this time when we click play, both wheels will move at the same time, which means that when we come to make presentation files, we can start to animate the scooter in a more realistic fashion. So that very quickly was driven constraints and motion constraints.